Hello and welcome everybody to this year's virtual World Conference. My name is Lars Knoll, I'm the Chief Architect of Qt. And I'm going to talk a little bit about what's cooking, what new things are coming, and some of the things that we've just have released to you. A lot has happened since last year's World Summit, and we've had a lot of focus, especially on the next major version, Qt 6. Which the majority of this talk will be about. But before we go there, let's have a quick look also at some other things. Let me start off with Qt Design Studio. We have released a new version of Qt Design Studio just a little while ago, Qt Design Studio 1.6. And I'm going to show you a few of the new features in there. Mainly, we've done a lot of work on simplifying the workflow, making it easier for you to use Qt Design Studio. For example, setting up textures and materials for a certain object becomes a lot easier now. You can just drag and drop textures onto Design Studio and connect things up. We've done a lot of improvements in the connection editor. It works now similar to the binding editor that we already had in there. And we have a new editor for transitions and animations, which is very much in line with how the timeline editor looks like. Another new feature is that we've added support for 3D effects to Design Studio. So as you can see here, you can easily add an emboss or other filters to the scene and add effects to that. We've also added a new flow view, which allows you to generate and design the flow of your application graphically. You can select different states of the application and do the transitions and edit the transitions in there, and even have decision points where you decide how things continue afterwards. The next thing is that we've also added support for better or improved support for Qt for microcontrollers, Qt for MCU. As you might have heard, Qt for MCU is our product that brings Qt and the Qt Quick technology to microcontroller type processors. There are certain limitations in there, and not all the features and all the bells of whistles of Qt Quick are available in Qt for MCU. With the new improved support, we are actually showing you what is available and what's not available. We automatically disable the functionality that you cannot use in Qt for MCU if you choose that as your profile. With that, let's move over also to Qt for microcontrollers, where we released version 1.4 a little while ago. It's very much an incremental release on top of what we've done before. So the focus is to be able to bring Qt onto small embedded devices, microcontroller style devices with not a lot of RAM, not a lot of ROM, and rather low-end processors. We've added support for a few more processors there, but the main thing that we've done is to add support for the Monotype Spark engine. Fonts and text are usually one of the biggest memory hogs in these kind of applications, especially if you're targeting countries outside of Western Europe or North America. If you need to support multiple languages in your application, you need to support Asian fonts. The memory usage of those go up very quickly. And as you can see here, memory usage of those kind of applications, if you want to, for example, use that with a Chinese or a Japanese font, is rather high. Monotype Spark engine helps there to bring that memory usage down significantly. And with Qt Design Studio 1.4, you can easily use that. It's just a compile switch away, just a configuration option to enable that font engine, and with that, reduce the ROM consumption of your application by a large degree. With that, let me now move over to Qt 6, our next major version that we're looking at and that we've been developing over the last year. We've been spending a lot of time and effort getting Qt 6 out of the door and making it ready for you. There's already some versions available, pre-release versions that you can try out. Go ahead and try them, but let me also show you now what's in the package and what we've done. Let's start off a little bit with the high-level goals that we've had with the development of Qt 6. The main focus here has been to prepare our product for the future, for the next years to come. We wanted to make sure that we can fix architectural limitations that we've identified in Qt 5. Make sure that we can work on performance, improve those beyond what we were able to do within the Qt 5 series. Of course, with making things ready for the future, there's also a bit of house cleaning that's happening. So we've been removing old deprecated functionality and generally cleaning up our code base. We've been working towards supporting package management and making it easier to actually add additional packages to the product in a separate way. I'll talk a bit about that later. And with that also comes then a smaller and more modular core product. Last but not least, of course, one of the goals has also been to have a good compatibility with Qt 5. Before going into the details of the features, there's also a couple of things that we need to remember when we think about compatibility and what's important for you for Qt, what's important for you as a user of Qt as a product, what makes Qt valuable, what are the core values behind it. And those we need to really take care of when we develop the new version. Those values are things like being cross-platform, working on all major desktop, mobile and embedded operating systems. The maintainability of the code base that you are writing is really important for us. And of course, also with that comes the fact that we need to be compatible as much as possible with previous versions. We want Qt to be scalable from very low-end hardware to big desktop systems and distributed systems. Intuitiveness and ease of use are important. We want to make sure that we have a great documentation that also helps you there and great tooling around it. So those are the core values, and we've really tried to make sure that when we do develop Qt 6, that we took care of those and had those in the back of our minds at all times. But having said that, the focus for Qt 6 has not been to develop lots and lots of new features and functionality. The focus was to clean up the code base and our architecture. That has been at the heart of the work that we've been doing, making Qt ready for the next years to come, and then being able to develop on top of Qt 6 new features in a much faster pace. So compatibility is one of the most important things. Qt 6 is mostly source compatible with Qt 5. We've done our best trying to get in the new things that we believe are needed for the future while keeping everything that you've been developing over the years as much working as possible. Nevertheless, some porting will be required when you move your code base from Qt 5 to Qt 6. It will require a few changes to the source code and of course a recompile. We've removed all the deprecated functionality, so if in case you're still using some of that, you will need to refactor your code base, get rid of that. But those changes are really there to prepare us for the years to come. One major change we've been doing is to bring Qt up to a new version of C++. We're now using C++ 17, all the features that are available there in our own code base, and require with that more modern compilers than we used to in Qt 5. We've done a lot of work also in terms of our low-level infrastructures. Inside our core libraries, the containers have received a lot of attention, and we've done a lot of changes there to simplify things and make them ready for the future. A big change that we've done is that we've brought QList and QVector together. They're now one class in Qt 6. We've fixed some of the implementation issues that we had in QList in Qt 5, made it fixed some performance issues there, and made then also a QVector an alias to QList. They're the same type as said. We've improved our 64-bit support by making sure that all our containers can handle more than 32-bit or 4 billion items. We've rewritten QHash and QMap, making them more modular. QMap basing those on the standard containers, and QHash having its own new implementation. I'll talk more about those in a separate talk later on in this conference. So if you want to hear all the details, come to that talk. And we've done a lot of work also to fill our API gaps that we had towards the standard containers. Things like move operations, supporting those consistently, emplace, ranges, and initializer lists. We've done work on Unicode and our string handling, making sure that all our text handling in Qt 6 is Unicode based. We assume that source code nowadays is UTF-8. That's something that is the default on pretty much all compilers nowadays anyway. And we've cleaned up our string-related classes to make that a more consistent set, added explicit support for UTF-8 as a text encoding, and we moved legacy encodings out of the core libraries into a set, so that we basically have a more consistent story around Unicode there. One of the big new features and architectural enhancements we've been doing for Qt 6 is adding support for bindings. Bindings is a concept that we first introduced in our Qt Quick and QML language, where you can have relations between properties that we always keep up to date. So you can basically say this property depends on this other property with a certain expression, and we make sure the relationship is always kept alive. We've now brought this property system from Qt Quick back down into the base of Qt, into the core libraries, and make it available to the C++ side of Qt, and make sure that you can use it all over Qt everywhere. We've added a seamless integration with QObject, which is basically a simple extension of the existing property system, and we've added a new QProperty class that make bindable properties also possible outside of QObjects. Further improvements on the non-graphical side is we've added a Qt 5 compat module that will help you in the ease porting, where some of the deprecated classes of Qt 5 are still available for you for a time to come. We've done multiple improvements in for example, the networking stack, with SSL, TLS improvements. We've enabled HTTP2 by default, and you can also now write your own plugins to the Network Access Manager. Finally, we've also done a lot of work on concurrency and multi-threading with a fully rewritten Qt concurrent framework. I'll talk about that also in a separate talk, and you can get more details there. Moving up the stack into the graphical areas, we've done work there on unifying our pointer handling. Whether you have a mouse pointer or a touch device, a touch screen, or a tablet, those are actually specializations of a generic class, the pointer event, and not separate things anymore, where we share the data, where we have common data structures, and where we do also track the input devices that are associated with certain events and the history of those events points for you. And that helps resolve a lot of recurring issues and problems that we had in Qt 5 that were not easily solvable there, when you had to combine touch and mouse handling inside complex controls. For example, if you had a touch-enabled control inside a flickable, inside something that you could flick up and down, resolving those problems of who gets the events, who handles things, that's something that we can now do in a much, much better way. The graphics architecture has been one of the main things that we've been working on, revising that one and making sure that it's up to date with what the requirements nowadays are. When we 8 years ago did Qt 5, we thought that we could rely on OpenGL as the cross-platform API for doing 3D and 3D graphics. The world has changed over the years now with the introduction of Metal, Microsoft staying with DirectX 11, Vulkan has been added. So we now have a multitude of different platform APIs for doing 3D graphics. Qt, of course, wants to make sure that this is not a problem for you. We want to have a cross-platform, a unified layer on top of that and work with those native APIs. And a lot of the work that we've been doing over the last 2 years in the graphics area has been to develop that framework. It's called the Qt RHI, the rendering hardware interface, and it's a common layer, thin layer on top of all of those platform APIs that gives us a common abstraction for those graphics APIs and allows us to build our graphics stack on top of it. We have then with Qt 6 now a unified scene graph for Qt Quick on top of the rendering hardware interface, and Qt Quick 2D and 3D works on top of that. To the side, there's a new module called Qt Shader Tools that I'll talk about in a second as well. And finally, on the top, you have the tooling, Qt Creator, Qt Design Studio, where you can implement all of those things in a cross-platform way. Quick look at the rendering hardware interface. This, as I said, is an abstraction layer for 3D graphics APIs. We're supporting nowadays OpenGL, OpenGL-ES, Metal, DirectX 11, and Vulkan. And it abstracts all the common graphics objects, materials, meshes, shaders. It is, for now at least, an internal API tuned towards the needs of Qt, the needs that we have to be able to offer you a cross-platform high-level API on top with Qt Quick. It's integrated with the Qt platform and Windows system abstraction layers. And with Qt 6 now, Qt Quick and Qt Quick 3D are fully ported to that rendering hardware interface. Together with that abstraction layer comes a new module called the Qt Shader Tools. Qt Shader Tools help you write shaders in a cross-platform way. It enables that support for you. So it allows you to write a shader once and then recompile it to all those graphics APIs. So you write your shader in a Vulkan-style GLSL, and then you can recompile it to the Metal shading language, to DirectX 3D shading language HLSL, or to OpenGL to be an OpenGL shader. And we have support for that both at runtime and at build time. So the big takeaway and what's really important to note is that Qt 6 uses the native graphics API of each operating system. We're not using OpenGL on all of those operating systems anymore. We're now using Metal on macOS and iOS. We're using DirectX 3D on the Windows platform, and we're using Vulkan on Vulkan-enabled devices, or Android, for example, modern Android systems. Qt Quick 3D has been a large focus area for us over the years. This is really adding full 3D support to our Qt Quick technology. Qt Quick has traditionally been focusing mostly on 2D user interfaces. With Qt Quick 3D, we've now added all of the 3D support that is required there. And you can see a lot of that is already available in 5.15. But with Qt 6, we've taken one step further. We've brought it over to use the rendering hardware interface. And we have now one scene graph that allows you to very efficiently combine both 2D and 3D in one scene. We've done a lot of work to optimize support for external assets that you create in content creation tools. So we've enhanced our PBR support so that materials that you design in a tool such as Blender or Maya really look as they are designed. We've greatly improved the support for GLTF2, supporting the base spec and most of the common extensions. That together will give you a great new functionality there and allows you to do a lot of cool and new things in 3D with a very good performance. Qt Quick Controls, another piece of our Qt Quick technology stack, is something that also has received a lot of attention. And one of the goals for us there was to bring that back also and make it usable on the desktop platforms. As you might know, in Qt 5, Qt Quick Controls had their own look and feel, and the stylability was rather limited. In Qt 6, now we've brought support for desktop styling to those Qt Quick Controls. So you can get the native look and feel on macOS, Windows, and Linux as well. Here you can see one example with a dark style, metal dark style. And on the next, and here there's an example showing the Fusion style on Linux. So those are some of the big changes and improvements that we've done inside the Qt frameworks. But we've also done work surrounding that. We've been working on our build system and changing that over to CMake, as I've talked about already last year. So far, Qt has always been built using our old build system, QMake, but we've been changing that now over to the standard CMake tool, which is the standard for most C++ projects out there and what many people use. This has the advantage that you're also getting a much better CMake support for your application and if you are using CMake. We're using it also consistently to build Qt ourselves. QMake, the old build system, will still be there and supported, so if you have a QMake-based project, there's nothing for you to worry about. You can just bring that over to Qt 6 and continue using it. Package management is another big topic that we've been looking into. We wanted to make sure that it's easier to discover additional content, make it simple to use that and integrate that with the Qt installer, so that we can modularize things. And the package management system that we've been working on is then going to be a delivery mechanism for most of our supported add-ons and third-party content and tools. The big advantage here is that we can decouple release cycles from the Qt releases. We can with that reduce the size of the core Qt deliverable, making it easier to work on minor releases of the core product, and can also release add-ons at their own cycle, so that whenever we have new functionality available in an add-on, we can release a new version easily for you. Another advantage for you is that you can only install what you need, reducing the size of your download code, making things better in that respect. And we have a more reliable release process getting things out. So, as I said, this means we have a smaller core product for Qt 6. Qt 6.0 will basically contain the essential modules: core, network, concurrent, GUI, widgets, QML Quick, Qt Quick Controls, and a good set of selected add-ons. The shader tools I've talked about. We still have our OpenGL module, OpenGL supports SQL, Qt Quick 3D, Wayland, SVG, and print support. And on top of that, of course, our tooling with Qt Creator, Qt Design Studio, and our build tools. So Qt 6 will be a bit smaller, and the additional content will come through the package management system. With Qt 6.0, we've also changed a little bit the amount of platforms we support. In 6.0, we're supporting Windows 10, macOS 10.15, and a recent Linux, Ubuntu 20.04, or some others, as the host platform, development platforms that you can develop on. Target platforms that you can deploy to are then all host platforms, Yocto 3.1 based embedded Linux platforms, iOS 13 and 14, and Android. Android version 28 at build time, 21 at runtime. So that's the amount of platforms we support right now in Qt 6.0. That leaves out a couple of the embedded platforms that we've been supporting in 5.15, but there's nothing to worry about there for you. We'll bring those back in 6.1 and 6.2. So QNX and the integrity are planned to be available as a technology preview with Qt 6.1 and fully supported on 6.2. The reason these are a little bit delayed are that the tool chains for those embedded operating systems were taking its time to fully support C++17, which is a requirement for us now. Many of you might also be wondering what's going to happen on macOS with Apple moving over to ARM-based chipsets to Apple Silicon. We'll be working on supporting that. If you're adventurous, you can already try some experimental support with 6.0, but we're planning on fully supporting that with Qt 6.1. And then, of course, in the embedded Linux side, we'll move along with the Yocto releases as they happen. The release roadmap, Qt 5.15.2 for the old Qt 5.15 releases will come out in November. That's the plan right now. Then we'll move over to Qt 6.0 in December. At the same time, approximately, we will also work on having a new major version of Design Studio out that supports Qt 6.0 and a new version of Qt Creator 4.14. 6.1, the next feature release after 6.0 will probably come then in around the first half of 2021, and 6.2 is planned for the second half. Then finally, let me give you an outlook of what's going to happen after 6.0. As I said, there are quite a few add-ons that are right now not yet supported in Qt 6.0 that we had support for in 5.15. So we'll be working on incrementally bringing those over to Qt 6.0 after the to Qt 6 after the 6.0 release. They'll be delivered through the package management system as they are ready. We're also going to work on other things like making all our properties bindable. I've talked about the new property system and making the binding support there. Not all of those are yet enabled in Qt, but we'll make that happen over the next minor releases. We're going to extend also the APIs for Qt Quick and Qt Quick Control and to have more C++ APIs available for you there. I know this has been a long, outstanding wish list item for many of you, that you wanted to have more control over those things from C++. We'll be working on that and hopefully have more and more APIs available there for you over the next couple of minor releases. And then we're working on rather large improvements on the QML performance that we can do based on the infrastructure work that we have been doing for Qt 6.0. So those are some of the good things that will be coming in the next couple of minor releases. With that, I'm actually at the end of my talk. I'd like to thank you very much for listening. And I hope you'll enjoy the rest of this conference.